Hi everyone, just wanted to take a minute to talk a little bit about rewriting radical expressions. We're predominantly just going to be simplifying numbers, but I will kind of touch upon a couple other things as well, just to make sure we're on the same page. So, just as a quick reminder, really, the square root that's what's undoing squaring, right? So if I had something like, x squared, how do you undo that? Well, you take its square root, right? The square root undoes the square. Um, Now, a perfect square is going to really just be a number that you know is the result of another number being squared, right? So 2 squared is 4, 3 squared is 9, 4 squared is 16, so on and so forth. Here's, all the way up to 30 squared. So these are really helpful when you are dealing with square roots, right? Because I know the square root of 25. The square root of 25 is 5, because 5 times 5 is 25. Right, the square root of 361 is 19, because 19 times 19 is 361. And that's going to be really helpful for us. As opposed to a number like, right, if I said, what is the square root of 19? Well, you're going to look at me and go, I don't know. And you're right, we don't. We would just leave it written as the square root of 19, because it's going to be, if you tried to convert it into a fraction or a decimal, it's just going to go on forever, right? So we would really just leave it in this notation. All right, so when you're simplifying radicals, there's an important property that you need to know. The product property of square roots is basically going to say that if I have the square root of something like this, right? The square root of 4 times 7. That's the same thing as the square root of 4 times the square root of 7. Now, why is that true? Well, right, we know from before, right, this is just equal to, well, what is this equal to? This is 4 times 7 to the 1/2. And, well, what do we know? We could distribute that, right? 4 to the 1/2, 7 to the 1/2. We know that from before, right, when we were dealing with rational exponents. So we're going to use that property to actually be able to simplify radicals, all right? So, for example, here we have the square root of 20. Well, what's the square root of 20? Well, 20 is the same thing as 4 times 5, which is equal to the square root of 4 times the square root of 5. Well, we know what the square root of 4 is. It's just 2. We don't know what the square root of 5 is, so we leave it alone. Now, you might be asking yourself, well, why didn't I pick something like the square root of 10? Or the square root of 2 times the square root of 10. I could, right? 20 is 2 times 10, but the problem is we don't know what the square root of either of these is, right? I don't. I mean, I would just leave them like this, so that doesn't actually help me do anything. This over here at least lets me know that I got a 2 out and the square root of 5, all right? So when we're doing this and practicing, what you're going to want to do essentially is you want to break up the number underneath the radical, which is called the radicand, into a perfect square and a number that's not a perfect square. All right. So my recommendation to you is, pull up a list of perfect squares, see which ones you can multiply times numbers to get whatever you're working with. Right. So, I mean, if you get something big, sometimes you might have to play around with it for a while. My other recommendation to you is, if you don't know, right, if you don't know, what you can start doing is, let's say I gave you find the square root of 336. Well, off the top of my head, I don't know exactly which square root I can pull out. However, if I divide by 4, right, I get 84, which means 84 times 4 would be 336. So, you could kind of do it that way. Now, if you get 4 to work, right, why not try 16? 4 squared is 16, so why not, right? Maybe it might work. It might not. In this case, it does. So, that helps you. But anyway, that's essentially the process you're going to go through. So again, see here, we have the square root of 63, 9, and 7. So 3 square root of 7. Now, you might be asking yourself, well, what do I do with something like this? What if I ended up with, what's the square root of 63 plus the square root of 20? And we just went over this. We said this was 2 root 5, and this is 3 root 7. This is it. I'm going to leave my answer like that, okay? So you cannot combine these unless they have the same radical. All right. I could, like, if it was 3 square root of 7 plus 3, 6 square root of 7, I can put those together and get 9 square root of 7. But I cannot combine these because they have different radicals. Kind of think of it in terms of like it's an x, if it, as a variable. It's not a variable, but like kind of mentally think of it in that regard for when you're adding or subtracting. Right, like 3 square root of 7 plus 6 square root of 7. Well, there's 9 square roots of 7 in total. 3 square root of 7 plus 2 square root of 5. Well, now there's 2 square roots of 5, and then there's 3 square roots of 7. That'd be like me trying to combine, x and a y, right? It's not exactly the same. All right. So let's rewrite this. So this one right here, 44, well, 44 is 4 times 11. Right? So this is just 2 root 11. And I'm done. Okay, now this one right here, you might ask yourself, what are you doing? Well, you're going to leave the 3 out front. You're going to ignore it. Okay? So you're just going to leave the 3 out front. We're going to worry about the inside. Well, what's 27? Well, that's 9 times 3. Okay? So now what do we have? We have the 3 out front. Do not forget the 3. It's very easy to forget. 3, what's the square root of 9? Well, that's 3 root 3. Now, this whole thing is just being multiplied, right? This is 3 times the square root of 27. So this is 3 times the square root of 3. Well, 3 times 3, you know what 3 times 3 is. That is 9 times the square root of 3. Okay? So do be careful. Do not forget about this. Do not try and bring it in to the radical. You should not do that. All right? You just will leave it out front, and then at the end, multiply by whatever you take out. Right? If you really wanted to put this into the radical, well, 3 we know is going to be the square root of 9. So if you want to put it all together for some reason, you'd have to rewrite it as the square root of 9. But anyway, let's do one more for good measure. All right. So if I had something like this, 1/5 square root of 50. Well, this is kind of nice because you have to be careful with what you pick. The square root of 50. First of all, it is very tempting just to rewrite this. Okay, it is very, very tempting to just divide the 50 by 5, but you don't do it. What you can do is you can break up the square root of 50. Well, so what's the square root of 50? Well, that's 25 times 2. So the square root of 25 times the square root of 2. 1/5, which is, this is 5. Square root of 2. 1/5 times 5 is just 1, so I just get the square root of 2. Okay? Right? So that, you need to be careful, right? Because if you had just divided by 1/5, you would have ended up with the square root of 10, which is not the correct answer. Right? If I really did want to put this in the radical, I would have had to rewrite this as essentially the square root of 1/25 times the square root of 50. Then I could have multiplied them, and it would have been 50/25, which is where we get our square root of 2. But anyway, just be careful. You do need to make sure you simplify out front first. And then don't forget about if you have any numbers out front. Now, before I end off, I do want to say a couple quick things. So again, when you are multiplying, you can combine them. When you are adding, they have to have the same radicand in order for you to combine them. One more piece of information. If you had something like, x to the 4th here, right? Well, what do we know this is? This is the same thing as x to the 4th to the 1/2, right? So you could rewrite this as x to the 4/2, which is just x squared, right? So do keep that in mind. If you have variables, you can kind of break it apart that way, using the 1/2 power, and kind of simplify it that way, where you would leave only like a 1/2 over here and then take everything else out. All right. Anyway, let me know if you have any questions, and have a great day.